with. So we're going to have to kind of come up with what that total number is going to be before we write the probability out. Okay, so in this one here, a 4-digit passcode was created randomly using the digits 0 through 9. No digits repeat. Find each probability. Okay, so you can't have a password of like 4444. You have to use a different one for all 4 digits that you choose. What is the probability that my passcode is 0123? Okay, and kind of like what we've been talking about throughout the week is the first number probably that we want to pay attention to is what's the bottom number. Okay, what's my total number? How many different combinations or possibilities are there in this? And once again, because it's a password, what of the two am I going to use here? Permutation, because order matters, right? Password is permutation, P and P. We have 10 digits to choose from, and we're putting 4 in our password. So we have 10P4. Out of those possibilities, which is 5,040, how many of them are the passcode 0123? Just one, okay? So there's only one correct passcode. Yesterday, on some of the problems, I kind of talked about drawing blanks, and I think drawing blanks on some of these is kind of helpful, just to kind of see what's going on. On number 2, the passcode begins with 8. So I already know 8 is the first number in the passcode. My other 3 numbers can be anything else that I want it to be. Okay, so here's how we're going to kind of get to that. First thing we're going to do, on bottom, okay, on bottom, how many combinations or possibilities or permutations will I have? Well, it's the same as what we had before, okay? It's still a 4-digit password, so that has not changed. Okay, if you want to write 10P4 again, you can, but it's the same as what we did on number 1. But now, on number 2, it says my passcode begins with 8, okay? So now we have 3 other slots that need to be filled, okay? How many numbers do we have left here? 9, okay? And out of those 9, we only have 3 numbers left. 8 cannot be used again because we already used 8, so we have 9 numbers left, and out of those 9 numbers, we're going to pick 3 of them for our passcode. So we do 9P3. Okay, always reduce. Okay, make sure these are reduced down. And so then that would be 1/10. Okay, let's jump to number 4. The password starts with a number that is no more than 3. Okay, so once again, the bottom number is still 5,040. Okay, we have the same number to choose from on all of these passcodes. 5,040 common or possibilities. Okay, on this one, the top is a little bit tricky. Okay. The first number in the passcode, the number in the passcode starts with a number that is no more than 3. So how many numbers are no more than 3? What numbers would be included there? 1, 2, 3. What else? 0. Okay. So 0, 1, 2, and 3. So in that first blank, we have 4 options. Okay. On number 2 right here, we only had the one option, 8. We already knew 8 was there. It told us 8 was there. Here, my first number in the passcode, I have 4 different options. It could either be 0, 1, 2, or 3. Okay? The other 3 can be anything that's not what I picked the first one. So if I picked 1, 1 is out. If I pick 2, 2 is out. Okay? But I have to pick something in that first slot. So the top here is going to be 9P3. I'm going to pick one of those 4 numbers in the first slot, okay? And then when I pick my next 3, I'm going to have 9 numbers to choose from, and I'm going to pick 3 of them and put them in that order. So we're going to do 9P3, which is 504, and we're going to take 504 times 4. Okay, the nice thing about most of your calculators is your calculators will reduce this fraction because the numbers are going to be a little bit bigger today. Then would typically be a little bit harder to reduce these, but most of your calculators should reduce this. If you don't know how to reduce on your calculator, ask, because it's pretty helpful. And you should get 2/5 for your answer. Okay. Be sure to ask me today if you don't know how to reduce on your calculator. That'll save you a lot of time. Okay, on number 5, Lexi is taking 6 classes each day next semester. If her schedule is randomly selected, what is the probability that she has math first hour, science second hour? Okay, there's 2 ways to do this. Okay, I'm going to show you kind of the easy way and the hard way. Okay, the first way you could do this is math and science are locked in, right? Those are your first 2 hours. We already know if she has math and science those first 2 hours. First of all, how many different ways, okay? Let's forget about this right here for right now. How many classes is she taking? 6. How many different hours does she have to fill? She has to fill all 6, right? She can't just take 5 hours or 4 hours. She has to fill all 6. So my bottom number here would be 6 factorial. You could do 6P6, which is the same thing, okay? But because we're filling a schedule, we're filling something in a particular order. Okay? Because math and science are already locked in, now I have 4 classes to choose from. And now you can fill it in with your electives or history or whatever classes you're going to fill in with the other 4 classes. Okay. And so that would be 4 factorial because we got 4 slots to fill. And we want to know how many different ways can we arrange those 4 classes that we have left. Okay, so we're going to do 4 factorial over 6 factorial. So do the math first, write it as a fraction, and then you can simplify your fraction. Okay, and I told you I was going to show you 2 ways. I think that's probably the best way to do it. You could just do 6 times 5, and then the other 4 classes can be in any order you want it to be. So I have 30 different ways to arrange those 2 classes because 6 times 5 is 30. If you include math and science in there as well. But I think that can be a little bit tricky to figure out sometimes. So probably still best to do it this way with the fraction and think about both scenarios. All right, let's jump down to the bottom part here. We have 4 freshmen, 7 sophomores, 6 juniors, and 3 seniors in the marching band, clarinets and the marching band. 2 are chosen at random to lead practice. Find each probability. All right, so the first thing that we always start with is the bottom number. Okay? How many people are in the band? Or in this section, I should say? 20. Okay? We got 20 players to choose from. Okay? And how many are we going to choose? 2. We're going to choose 2. Okay? So always do the bottom number first. That's the total number of possibilities. Now, do I want to use a C or a P here? Just a C. Yeah, because we're just randomly choosing 2 players, right? We're not saying, hey, we're going to put them in order, or we're gonna play in this order or something like that. We're just saying, I'm going to choose you 2, and you're going to lead the band. Okay? What is the probability that both of the people I pick are juniors? Well, how many juniors are there in the clarinet section? 6. So out of the 6 juniors, what's the probability that I would select 2 of them? Okay, so we're limiting. The top number should always be a little bit less, a little bit more limited, right? And we get 15 over 190. And then always reduce. And that would be 3 out of 38. Okay, number 8. The good thing is that if we're doing the probability of the whole section, the bottom number is not going to change, right? 20C2 is still going to be 190. Okay, now I want to know what's the probability of picking 2 people and neither one of them is a senior. So how many seniors are there? 3, okay? So if there's 3 seniors, how many non-seniors are there, Darston? Yeah. You might be able to hear better if you took your AirPod out. How many non-seniors are there? How many seniors are there? 19. Okay. 3 seniors, right? Yeah. So how many non-seniors? Oh, no. Okay, how many total kids are there? What? How many total kids do we have? Oh, no. Okay, you got to pay attention, okay? Bryson, help him out. How many non-seniors?
I don't know either.
Okay, that's why you guys need to quit talking and pay attention then. Okay? Okay, how many do we got? How many non-seniors do we have? 17. Okay? 17 non-seniors. And we're still just choosing 2. Okay? 17, choose 2. What is 17 choose 2? I don't have that written down. Yeah, and it does end up reducing down. Yeah, so 68 over 95 is our final answer. I probably would do these each individually. Some people like to try to put this whole thing in at once, and I mean, most of your calculators probably would do that, but I think there's more errors that could be made if you try to do it that way. All right, number 9 is a little bit tricky. One is a freshman, and the other is a sophomore. Okay? So the bottom number does not change, so that's the good thing. We know the bottom number is 190. Okay? The first person I pick I want them to be a freshman. So how many freshmen are in the group? 4. Okay. So we have 4 freshmen. I want to choose one of them. The second person I pick has to be a sophomore, and we have 7 sophomores. So that would be 7, choose one. What do you think we would do with those 2? Multiply them. Yep. So we'll do 4 choose 1 times 7 choose 1. Now here's the good thing. If I do 4 choose 1, how many different ways can I do 4 people choose 1? 4, because I have 4 people to choose from. Yep. And so this is really just 4 times 7, which is 28. And I have 28 over 190. All right, so the top part was all permutations. The bottom part was all combinations. Now we're going to kind of look at some mixture here. Okay, let's look at number 13. To win a certain lottery game, a player must choose 4 numbers correctly from the numbers 1 to 25. Numbers cannot repeat. What is the probability of winning the lottery? Okay, so here's the biggest thing, okay? In order to win the lottery, do those numbers have to be picked in a certain order? If I have 4 numbers on my ticket, do the numbers have to pop up in that order? You guys may or may not know this. Not necessarily, okay? Like, if you've ever heard of like the Powerball. Powerball is one of the ones that Kansas has that a lot of people talk about. Sometimes you'll see the billboard, and sometimes the Powerball's add up to like $1 billion. A couple years ago, it got up to a pretty good number. Most of the time, it's in the like hundreds of millions, like maybe 500 million. And so what happens in the Powerball is you get 6 regular balls, and then you have the Powerball. It's like a red ball. So you've got like a bunch of numbers in this bin. 6 balls are going to come out of it, and then you got another bin with the same number of balls in it, and a red ball pops out of it. Okay? You got to get all 6 numbers out of the white container, and you got to get 1 out of the red container all right. The order that they pop up in doesn't matter. You just have to pick the right numbers. So you have to pick these 6 numbers and the 1 Powerball number to get all the money. So order doesn't really matter here, okay? They don't have to pop up in that order. They just have to get those numbers pulled out. So this one here would be 25C4. We have 25 numbers, and I need 4 winning balls to come out. There's only one way to win. If I get all 4 of those numbers right out of the 25 that are being picked from, then I'm a winner. So this would be 1 out of 12,650. So that's not horrible odds. It's not great odds, but it's not horrible odds. But Powerball, if you figure out like what the odds are to win the Powerball, I mean it can be $100 million, right? Your odds of winning that are like in the probably 20. I think it's like 20 or 30 million. 1 out of 20 million chance of winning it. Okay, so your odds are not very good, obviously, of winning something like that because there's so many balls in the bin. Here, there's only 25 balls to choose from. I can't even remember how many are in like the Powerball, but you have a lot more balls to choose from, and so you got less opportunity to win. Okay, let's look at number 14. Jalen is deciding on what order to visit France, Italy, Spain, and England, and Germany, and Ireland within the next 2 years. If he randomly chooses the order, what is the probability that he visits Spain first? Okay, so the key here that we always want to pay attention to is the order, okay? He's not talking about just randomly visiting these countries. He's talking about order. he's talking about what is the order that I'm going to go visit these countries in. And so that would make this a permutation. How many different ways can I rearrange those 6 countries? So that would be 6p6 or 6 factorial if you wanted to do that. Okay, and that's my bottom number, which would be 720. Okay, if he chooses Spain first, Spain is the first country that he has chosen, then how many countries do we have left? 5, right? We had 6 to begin with. Now we have 5 countries left, and we've got to visit all of them. So that would be 5p5 or 5 factorial if you wanted to do that. And that would be 120 out of 720. And that would be 1 out of 6. Okay. 15. 3 letters are chosen at random from the word transformation. What is the probability that they are all vowels? Okay. First of all, how many letters do we have in the word transformation? 14. Okay. And we're going to choose 3 of them. Okay, how many vowels are there in the word transformation?
Unique or?
Just different ones. Yeah, not unique.
3. There's 3 unique ones.
3 unique ones. And here we're putting all 14 letters in. So I know, and we did talk about one yesterday. If we were doing like a password or something, we wouldn't know the difference between the 2 A's or the O's. But here we're putting all 14 into like the bag or whatever, and we're picking them out. We're randomly choosing all the letters in the word. So 5. A, O, A, I, and O. And we're going to choose 3 of those vowels. Okay, so it is a little bit different. That's why I wanted to talk about this one. If we were rearranging them, then which A is which, we don't know. But if I put all 14 in the bag and choose one randomly, then they're still going to all be included. So this would be 10 over 364. Okay, and I'm just kind of doing that, putting it in your calculator. Hopefully you know how to do that. If not, make sure you get with me to know how to put these in the calculator if you didn't get that yesterday. Okay, I think we'll stop there. Okay, so homework for today is the last homework assignment. We did the first 14 yesterday on the front side. So on the back side, we will do 15 through 22. Okay. It tells you in the directions, just to make this a little bit simpler, 15 and 16 are using permutations, 17 and 18 are using combinations, 19, 20, 21, and 22, you have to figure out which you're using, okay, one or the other. So you got to make a decision there of what kind. Okay. So the first 4 you know, the last 4 you have to kind of choose what's going on. So you still got 1 through 14 yesterday if you didn't get those done. Finish up that permutation combination sheet also. And then I did post answers to 5 and 6 yesterday, so you can check those. I know some of you have been asking